Time series problems are generally fairly simple problems. The service center at a large automotive dealership scenario is the type of scenario, though, that is designed to potentially trip you up if you lose track of the time series itself. Now, let me explain what I mean. A service center at a large automotive dealership is trying to boost revenue by providing no appointment necessary oil changes to any type of vehicle that stops by the service center. Okay, so that's why they need to forecast. To quickly estimate the number of these oil changes that the service center can be expected to complete in the upcoming week, the service manager has been using simple exponential smoothing. Okay, now that is a formula with an alpha value of 0.1. We might need that, so I'm just going to note it to the side. The number of no appointment necessary oil changes at the service center completed over the past 4 weeks listed here. Oh, all right, so there's this bullet point list 4 weeks ago, 3 weeks ago, 2 weeks ago, and it says the actual number. So I'm going to write a little reminder to myself that that list right there is actuals, 25, 36, 33, and 28. All right, now, last week, the service manager's forecast for the number of no appointment oil changes was 32.2. Now, forecast. We don't know what was forecast 4 weeks ago, 3 weeks ago, 2 weeks ago, but I am copying that number again to remind myself what it is we've actually been told last week when the manager used simple exponential smoothing with an alpha of 0.2. The forecast was this 32.2. Okay, fine. Now, what are actually the questions? A, what would be the service manager's forecast for next week? Now, this is a good example of what I meant by sometimes really simple problems can trip you up only because you need to figure out exactly what it is that's being asked. This particular problem, 4 weeks ago, 3 weeks ago, 2 weeks ago, last week, as in 1 week ago, essentially what's going on here is that that line that I drew right here is basically right now in that, and this is what I'm getting at, part A asks about next week. Picture it. Next week would basically be the next item in that bullet point list. Oh, all right. Now, why is it that's important? Because the service manager is using simple exponential smoothing. That's just a formula where your forecast equals your forecast from the period before plus alpha times what actually happened the period before minus what you had forecast would happen in the period before, right? That's just the formula. So to figure out what the forecast would be, you just fill in the formula. This right here, T equals next week. That means that to fill out this formula, I'm looking for the forecast for last week, T minus 1, back up 1, the actual from last week, right, back up 1. That's the key to filling out the formula. Let's see, the forecast, oh, that's what we were told. The forecast for last week, right, that's that 32.2 plus alpha, said was using an alpha of 0.1 times what actually happened last week. What actually happened last week was 28 no appointment oil changes minus the manager's forecast is again 32.2. All right, so I put that in my calculator and I get 31.78. That's the answer. If the manager stays with that methodology, then the forecast for next week would be 31.78, which is actually kind of awkward because we're talking about the number of no appointment oil changes, and there really actually isn't any such thing as 0.78 oil changes. One would assume that what the manager would actually anticipate was like about 32 oil changes, but at any rate, right, algebraically, the answer is 31.78. Now, part 2. What is the error in the service manager's forecast last week? Actually, we calculated that already when we calculated the exponential smoothing forecast, because error is actual minus forecast. And for last week, that is AT minus 1 minus FT minus 1, or that is the 28 minus the 32.2, right? Or negative 4.2. We'd say, well, you know, last week there was an error of a negative 4.2. Okay, there, that one's done. Now C. Suppose the service manager decided to use a 3-week moving average. Okay, so we're throwing out exponential smoothing. Now what would be the service manager's forecast for? Again, we're talking about next week. We're talking about the new bottom row on this list. Okay, a 3-week moving average. That's easy. All we have to do with any moving average, the only thing you have to do is average that many past actuals. So in the case of part C, here's next week, we would want to back up and grab these 3 for 3-week past actuals. Okay, could do that. That's 36 from 3 weeks ago, plus 33 from 2 weeks ago, plus 28 from 1 week ago. We're averaging, so we divide by 3. So in that case, the forecast for next week would be 32.33, the result of using a 3-week moving average. For this problem, that's pretty simple to compute. Look out for one of the most common errors on this problem, and that's that people realize, I'll just grab 3 weeks. They stop at the top of the list instead of the bottom. Remember, however the data is laid out, you want to grab that many past periods and then just average them. It is that simple.